Alright, so let's have a look at another electromagnetics question. So we are told a step-up transformer is connected to an AC generator that delivers 8 amps at 120 volts. We're told the ratio of number of secondary turns to number of primary turns is 500. So there are 500 turns on the secondary side for every one on the primary side, or equivalent. And then we're asked to find the EMF across the secondary coil, find the power input, find the max power output, and then find the current in the secondary coil. Okay, so we're going to start by drawing a diagram. So this is our transformer. It has some input coil over here, like so. This is voltage primary is 120 volts, and we're told current primary is 8 amps. Number of turns on the primary side, we have no idea. Number of turns on the secondary side, we have no idea. We know the current secondary is unknown to us. So current secondary, this is unknown, and voltage secondary is actually unknown as well. So first, we want to find the EMF across the secondary coil. This is voltage secondary. So to do part A, we happen to know a formula linking voltages and the ratio of turns. We know Vp on Vs is equal to Np on Ns. We know voltage primary is 120. We need voltage secondary. So this means voltage secondary is voltage primary times Ns on Np. This gets flipped upside down. So we were told Ns on Np is 500. Primary voltage is 120. So this tells us that voltage secondary must be 120 times 500. If we put this into our calculator, this is going to be 60,000. So this is 60,000 volts. So voltage secondary ends up being 60,000 volts. So this is the answer to part A. Now for part B, we are asked to find the power in. So what is the power input? Well, power in is voltage in times current in. The voltage in is 120. The current in is 8. 120 times 8, that's 960. And this is in terms of watts. So the power in is 960 watts. For part C, we're asked to find the max power output. Well, the maximum power output is the power input. So max power out is equal to power in. In an ideal transformer, power in is equal to power out. In a non-ideal transformer, power out is actually slightly lower. But in the maximum case, it'll be whatever the power in is. So this is also 960 watts. And then the last part here says find the current in the secondary coil. Well, we know from another ideal transformer law, voltage primary times current primary is voltage secondary times current secondary. The only one of these we don't know is current secondary. So we can rearrange this for Is by dividing both sides by Vs. Divide both sides by Vs. This tells us current secondary is voltage primary times current primary divided by voltage secondary. Vp times Ip is 960. Just calculated this. Divide this by voltage secondary, which is 60,000. And this tells us that the current on the secondary side is going to be 1.6 times 10 to the minus 2 amps. So on the secondary side, this is a very low current. And this is the answer. And this is how we do this question.